And now, when we know the position of the plane in a space, let us speak about the position of different planes on the complex drawing. Depending on the position relative to the projection planes, there are planes of general position and planes of particular position. General position plane is a plane inclined at any free angles to the projection planes. You can see this example on our drawing. We can say that the plane of general position is not perpendicular to any of the position planes. On this drawing, you can see this example. It's the example of a general positional plane. We have three projection planes. Horizontal plane is marked with letter A. Frontal plane is marked with letter B. And profile plane, this plane is marked with letter C. The plane of general position is defined with the points P, Q, S. If this plane was perpendicular to any of these given planes, horizontal, frontal, or profile, then it would be projected on this plane in a straight line. But we see from our drawing that the projection of the plane PQS is projected on any other plane as a triangle. So, the PQS plane is the general position plane. Don't forget, at the beginning of our lecture today, we have learned with you the visibility of different lines. And on this example, I show you that not all lines are visible for us on this drawing. Some lines are closed, are covered with the plane PQS. The planes of a particular position can be divided into two groups: projecting planes and level planes. Projecting planes are the planes perpendicular to any projection plane. Planes parallel to one of the projection planes are called level planes. The example of a horizontal level plane we can see on this drawing. All objects lying in the plane of the level are projected on a parallel plane of projections in full size. Horizontal plane of the level, a plane parallel to the horizontal plane of the projections. We have triangle ABC lying in the horizontal level plane. This triangle is projected on the plane pi1 in full size. On our right drawing, you can see the projections of this triangle on the horizontal projection plane and on the frontal projection plane. On horizontal projection plane, we have triangle A1, B1, C1 in full size. And since our horizontal level plane parallel to the horizontal projection plane, and it means it is perpendicular to the frontal projection plane. On the frontal projection plane, we get a straight line, and that will be the projection of the level plane on the frontal projection plane. And on this line, we project the points with the help of communicating lines, point A2, B2, and C2. Front plane of the level on this drawing is a plane parallel to the front plane of the projections. Now, our triangle ABC, lying in the frontal plane of the level, is projected on the plane pi2 in full size. On our right drawing, you can see that on the frontal plane, our plane is parallel to the frontal plane. We project the triangle ABC in full size. We get the points A1, B1, C1. And as you can see from the left drawing, our frontal level plane is perpendicular to the horizontal projection plane. It means that this plane is projected in a straight line on the horizontal projection plane. And it means that we project all the vertices of triangle A1, B1, C1 on the horizontal plane on one line, on the line parallel to the horizontal plane. That's this drawing. Profile plane of the level is a plane parallel to the profile plane of the projections. Triangle ABC, as you can see from this drawing, is lying in the profile level plane, and this triangle is projected on the plane pi3 in full size. From the right drawing, you can see that we have triangle A3, B3, C3 in full size on our profile plane pi3. And on our frontal plane pi1 and horizontal plane our frontal plane frontal plane is pi2. And our horizontal plane pi1, we have straight lines, because our profile plane is perpendicular to the frontal projection plane and horizontal projection plane. That's why we depict the vertices of the triangle A3, B3, C3 on the front view like the straight line. It is B2, A2, C2, and the same will be on our horizontal line projection plane. We have a vertical straight line, and the vertices of the triangle are located on this straight line A1, B1, C1. That's the example of a profile plane of the level. Another types of the planes. Planes perpendicular to one of the projection planes are called projecting planes. On this drawing, we can see the example of horizontal projecting plane. It is a plane perpendicular to the horizontal plane of projection, pi1. The horizontal projecting plane is given by the horizontal trace of the plane. This trace of a plane is marked by letter Q. The trace of the plane is the line in which the plane Q is projected on the plane pi 1. Our plane is perpendicular to the plane pi 1. It means that on this projecting plane, horizontal projection plane pi 1, we have only a line, and this line is named the trace of the plane, and on our drawing is marked with letter Q. The angles of inclination of the horizontal projection plane to pi 2 and pi 3 are projected on the horizontal plane of the projections in full size. So, on our right drawing, we can see that on the frontal projection plane, we have the image of the triangle ABC, A2, B2, C2. On the horizontal line, on the horizontal projection plane, we have a trace of our plane, a straight line inclined to the horizontal line. And this line is marked with letter Q. We should project the vertices of our triangle A2, B2, C2 on this straight line on horizontal projection plane. And we get points A1, B1, C1. We also can mark the angles between the angles of inclination of this plane to the horizontal projection plane and profile projection planes. On our drawing, you can see that we have angle beta and gamma. This drawing shows the example of a front projecting plane. Front projecting plane is a plane perpendicular to the front plane of projections, pi 2, and is defined by the front trace of the plane, S2. You can see this on our left drawing. The projections of all lines and points lying in the front projecting plane coincide with the front trace of this plane. The angles of inclination of the front projection plane to pi 1 and pi 3 profile plane are projected on the front plane on the projections in full size. So, on our right drawing, you can see that when we have the front projecting plane, it means that on the horizontal projection plane, we have the shape of triangle ABC in full size. We get the triangle A1, B1, C1. And on the front projection plane, frontal projection plane, we have only a straight line, the trace of this plane, S2. And the vertices of the triangle ABC is located on this straight line. With the help of communication lines, we projected the point A1 on the trace line to the point A2. Point B1 is point B2 located on the trace line, and point C1 also is located on the trace line and is marked like C2. 2. We also can find and can mark on this frontal plane the inclination angle to the frontal projection plane. It is angle alpha, and to the profile projection plane it is gamma. So that's the example of front projecting plane. And at last, let us discuss profile projecting plane. It is given on our drawing here. Profile projecting plane is a plane perpendicular to the profile plane of projections. Pi 3 is defined by the profile trace of the plane G3. This example, from this example, you can see the position of this plane in space. So we have the projection of our triangle on the front projection plane and on horizontal projection plane in full size. We have triangle A1, B1, C1 on the horizontal projection plane and triangle A2, B2, C2 is the projection of triangle on the frontal projection plane. And on the profile projection plane, pi 3, we have only a straight line. It's the trace of the plane G3. And on this straight line, we should project the points, the vertices of triangle ABC. So on this straight line, on the profile plane pi 3, we get points A3, C3, B3. We also can mark here the angle of inclination of this plane to the frontal plane and to the horizontal plane. It is angle alpha. It is the angle of inclination to the horizontal plane, and angle beta, the inclination angle to the frontal plane. Now, let us look at the problem of determining the common elements of various geometric shapes. These include tasks of the belonging of geometric elements, for example, taking a point on a line or on a surface, draw a surface through these lines, and tasks are on the intersection of various geometric objects, determining the points of intersection of a straight line with a plane surface, tasks of the intersection of planes on determining the line on the intersection of surfaces.